climate approach with heavy metal. Um, this work is from one of my students, Márcia. So if you have any questions, you can ask her. She's 18,000 kilometers away, so don't worry. Uh, she couldn't come, of course, so I'm going to present. The motivation is natural-based solutions. It's in our um, schedule, is in our prime time everywhere, but it's not only planting trees everywhere, as you know, and some of you have been talking about. So my question is, how can we project better cities with natural-based solutions using other methods, and where to implement this particular case of trees, because they have provided several services, but one of them is to reduce temperatures in cities. Lisbon, three places, very different places. I work with a municipality, and when they ask me, where do you put here the trees, and I say, you don't need to put trees here. You have shadow. It's much better than the trees. But some streets are very efficient on this, but worse ventilation. But places like that, the Praça do Império, it's the entrance of Lisbon, where the sailors went to New Worlds in the 16th century. They don't want to plant trees because it's against the logic of urbanism in such an imperial place to plant trees. So how can we help? And we have other places like that garden in Lisbon. As you have mentioned, loans are very less efficient if they are not irrigated. If and we have a problem in Mediterranean areas, that is, we don't have water. We have a scarcity of water. How to use water for these spaces? And for instance, in this space, in other like this, sometimes the temperature is much higher during the day if it's not irrigated than shadow spaces. So we need to carefully look at these natural-based solutions. So where to implement these trees when space is cramped, and how long must we wait until these solutions are effective reducing the heat? For instance, if we plant a tree now, it's going to be efficient in maybe in the 10 years from now, and many of us we cannot be here, so we must tackle now this problem. So the experience of Márcia, she has been okay. Yeah, sorry. Can you help me, please? Help. Thank you. No.
The bottom one is the back.
This one? Okay. I was clicking the wrong side. So Márcia took one neighborhood in Lisbon, in the northern part of Lisbon, two streets very different, one north-south oriented and the other one east-west oriented. So the facades are very different, and they have gains and loss of solar radiation very different. And we also choose this place because we have quite a similar painting for all these buildings, and they are especially rose, white, and gray. So now this is the so. Let's go on. Let's move on. We had several stations, urban stations here, 3 or 4 stations, and she made uh, thermal camera images to compute the temperatures, the surface temperatures in the facades. And as we can know, the north facades generally have less temperature than the south facade. This is informal, empirical. We know this, but we don't know how much. So the first question that I would like to send here is, um, should we plant trees near the north facade exposed because they are less heat than the south facades. Of course, maybe we can help urbanists to relocate the trees or to plant the trees where temperatures are higher in the urban areas. So this is the east-west facade. We know there are several characteristics, like for instance, during the morning, 9 a.m. and 1 p.m. temperatures are higher in the east facade because we are in the northern hemisphere, and the west facade receive more radiation in the late afternoon. So this is another information that is good to make decisions. So we had three kinds of surfaces. That was facades, and now the soil, the street. We have asphalt, white tiles, and Portuguese traditional pavement. I think only in Portugal, in Brazil, in Rio de Janeiro, you use this kind of pavement. It's a small limestone pavement. We can see on this at several times that most of the time the asphalt is as temperature higher than the other ones. This is known. So this is just the result of the relative balance of this horizontal horizontal surfaces. So asphalt is always higher temperature, and also they have higher net radiation during the day. And here we have second stage on this research. It was making simulations with EnviMet, and what she did was to change the surfaces to see if we can have an improve, a positive improve or a negative improve. And so darker surfaces mean lower temperatures during the day, but higher temperatures during the night because of the net balance. So our discussion here is yes, we need natural based solutions. We need trees in our cities, but we cannot have trees everywhere. We have several studies in Lisbon, and we know the many trees we plant in the streets, the many trees fall down during thunderstorms and other storms, and windstorms, especially windstorms. So plant trees is a delicate, is a chirurgical science. So we suppose that with kind of modeling and with this kind of measurements, we can say where to locate, where are the best places, and of course, in the facades that get more energy and more temperature. And of course, we need better, efficient surfaces, of course, not only natural-based solutions, and we saw yesterday, 2 days ago, Dr. Santamuri is talking about the new materials. We also need, in complement of nature-based solutions, or nature-based solutions should be the complement of these new materials that can help us to make more efficient, thermally efficient surfaces. Okay, so I think we are on time. Thank you for your attention.
Thank you, Dr. Lopez. Do we have any questions for him? Elena will have a mic to go around if you have any questions for him. I always have an initial question. So you guys were using, you and your student were using NBMet to do some of these analyses. Were you looking at just those surface temperatures within NBMet, or were you also looking at air temperature and some of the other thermal comfort metrics?
Of course, we have thousands of outputs with EnviMet, so analyze every one. It's not weird that because I'm just presenting. We have only time here to present one example, but of course we simulate everything and we compare with measurements, because we have measurements in the urban canyon. We have small stations there for at least almost 1 year. So we made comparisons, and for this particularly urban canyon, the EnviMet was the simulation for close to the results we got from the measurements.
Okay. Any other questions? I hope I can give a chance there. David, here at the front.
Thanks. You were mentioning at the end that high albedo surfaces are more efficient than low albedo surfaces, and I think that would all agree if we're talking about, for instance, roof surfaces. But when you're talking about ground materials or even wall materials, what about reflected solar radiation that's reflected onto the body of pedestrians, for example?
Yeah.
Then what happens with high albedo materials?
Yeah. It's a problem, yes, because many parts in the city with high reflection blinded our eyes. So sometimes we get, I don't know the term in English, but flared by the light. So that's why our point is we need to help the technicians in the municipality and urbanists to locate the better. The same as I said to the trees is the same we said to surfaces. Efficient surfaces should be out of our eyes. So maybe we have also to do more research to see where to implement these surfaces.
I think we'll move on for now, but thank you, Dr. Lopez.